This is the Robertson Model 432 Mark II process camera. It measures 43 inches wide, 32 inches deep, 57 inches tall, and weighs approximately 400 pounds. Other names for this camera were the copy camera, repro camera, photostatic camera, or more commonly, the stat cam. There were horizontal and vertical models, this being a vertical model. The stat cam used large sheets of film for large format photography. The process camera was invented in Kansas City by Oscar T. Gregory in 1907 and became the Gregory Commercial Camera Company in 1909. The camera was called the photostat, or StatCam for short, and became a common name for such cameras from then on. In 1910, the company was located in Rochester, New York as the Commercial Camera Company and had a special relationship with Eastman Kodak. At the same time, there was a competing camera called the retinograph camera, also located in Rochester, New York in 1906. The retinograph would eventually evolve into the Xerox Photocopier Company. The StatCam is a large format camera originally designed to photograph objects to film. It was also used more often to copy printed articles directly to a photosensitive paper as a form of fast, cheap printing. Other uses were to create color printing plates for printing processes such as offset lithography, photozincography, and heliozincography. Over time, the StatCam was widely used by newspaper and magazine printers. These StatCams were horizontal and quite large and based on a horizontal carriage. Film sheets for these monsters would often be 48 inches square. In later years, smaller vertical versions were made for the graphic arts industries of the 1950s. These versions of the StatCam evolved into being used by slide makers of the multimedia businesses of the 1960s and the multi-image business of the 1970s and onward. Here the approach was to make the artwork for graphics and slides large and the final product was photographed small so tiny imperfections would disappear. It was also easier to make complicated graphics in large scale. In later years of the StatCam included computer automation, but was still the same principle of earlier cameras. When slide making was ended by computer technology of the 1990s, so was the StatCam and many were quickly scrapped. Robertson Photo-Mechanix was based in Chicago, Illinois, and then Des Plaines, Illinois, building several models of process cameras before going out of business. This model requires 18 amps of 240 volt electricity, however all the components use 120 volts supplied by a very large step-down transformer. It is speculated that 240 volts was used to make facility wiring easier, as over 32 amps current of 120 volts would be required, and that could be costly to install. There are four major components to the Robertson process camera: the copy platen, the lens, the control panel, and the film head. The copy platen is made of a glass top cover with a spring-loaded glass sheet below so as to sandwich the art copy flat between the two glass plates. There are four 500-watt lights along the sides of the platen for top lighting of the artwork. There is an alignment grid mat that can be inserted into the glass sandwich plates. This grid also appears on the focus glass and the film head. Copy art such as books or objects can be placed on top of the platen or in between the two glass sheets. The copy platen can be raised or lowered by a hand crank to the desired position. This position would determine how large the photo image will be. The copy platen has two position tapes that would indicate the position of the copy in relation to the lens or film. The copy platen is also equipped with 8 fluorescent lamps and 4 incandescent lamps for the use in backlighting transparent artwork in the opaque mode that will be discussed later. It is speculated that the two different types of lamps were used to provide a wider range of color temperatures. The lens is a large wide lens by Nikon with a large setting handle to adjust f-stops and is easily removed for cleaning or to change to a different lens. These are examples of other sized lenses that may have coordinated with the auxiliary lens settings. The lens is also raised or lowered by a hand crank. There are two position tape indicators for the lens similar to the copy platen measure tapes. The shutter is located just above the lens and is operated by an electromagnet. The control panel is quite simple. There are no complicated electronics or microprocessors to program. Even the timers are mechanical. The copy platen and lens movements have a calibrated positioning tape attached that is displayed on the front control panel. They each have two such tapes, one for when using the regular lens and the other for when an alternate lens is used. The use of these tapes is one way that the camera can be focused. The position tape is marked in increments that refer to the percentage of the image that is to be exposed to the film. If 100% of the original image size is to be exposed to the film, then the copy and lens platens are set to 100. If a 50% reduction is the goal, then the platens are set to 50. If a 50% enlargement is the goal, then the platens are set to 150. Another technique of setting the image size is by the dimension of the artwork. This technique requires the use of a circular proportional scale. The outer ring of the dimensions is the size you want, and the inner ring of the dimensions is the size you have. When you turn the rules to match, then a percentage is displayed in the inside window. This is the percentage that is used to set the copy and lens platens of the camera. This is the 1954 Robertson percent ease calculator. Not only did it provide proportional percentage information, but also provided f-stop information as well. This is the 1967 Robertson percent ease calculator. In addition to everything else, it also provides information for exposure time. To the left of the position tapes is a switch for lights behind the position tapes. Next is the master power switch and a switch for focusing the camera. The focus switch turns on the copy lights and opens the shutter. The next switch is to select the intensity of the top copy lighting. The first timer is for photographing opaque artwork or objects. The timer is a dual-range timer made by Industrial Timer. The small button select the timer has a 1 minute or 3 minute maximum range. Once the range is set, the countdown time is set by the silver dial. When the start button is pushed, the top copy lights turn on and the shutter opens. When the timer is complete, the shutter closes and the lights turn off. The next timer, called the no-paic timer, is used for when transparent artwork is to be photographed. The term no-paic is most likely a catchy term the manufacturer used for this feature for transparent art or art that is not opaque. The timer functions just as the previous timer. When activated in the manual mode, the lower lighting turns on and the upper lighting stays off, and the shutter opens. When the timer is complete, the shutter closes and the lights turn off. When the switch is set to auto and the focus switch is activated, the shutter opens and both the bottom and top lighting turns on for focusing. If only backlight is required for focusing, then the top lights must be unplugged from the back panel. When using the automatic setting of the Nopaic feature and the start button of the Opaic timer is pressed, then both timers run with both top and bottom lighting activated to their respective timer settings. This feature was mostly used by people in the print industry, but not so much by other graphic artists. The film head is at the very top of the camera. It is made up of a hinged vacuum platen that holds the film in place. The film head has two methods of hinging open that is set by two knobs at the top. In this position, the film platen can be easily loaded with film. With the knob set the other way, the film head can fully open towards the back so the operator can see inside to focus and to place or remove the focus glass. One option of focusing the camera is a frosted or ground glass that has an alignment grid printed on it. The glass has transparent stripes on it so the operator could see other focus reference points if desired. The focus glass is placed in between the top of the lens and the film head. When the focus switch is activated, the copy lights come on, the shutter opens, and now the art copy becomes visible on the glass so sizing and focus can be adjusted. Once positioning and focus adjustments are made, the focus glass must be removed before exposing the film. The top of the film head has a perforated vacuum suction surface that holds the film in place. The vacuum surface also has the same alignment grid as the copy platen grid mat and the focus glass printed upon it. There is a hose that connects the vacuum surface to the vacuum motor off to the side of the camera. The vacuum motor is controlled by a foot pedal. Sometimes film must be loaded in complete darkness. One trick to help this process was to place magnetic strips where the film will be placed so that the operator can feel in the dark where the film is supposed to go. The camera operator for multi-image graphics would often tape an Acme peg bar in a specific location to enable film and image registration. However, one must be careful to grind down the pegs or else they will punch into and crack the focus glass if one was so careless. A second peg bar is taped to the copy platen in the exact same position according to the alignment grid. Here are the steps that a camera operator for the multi-image business might have used to make a codolith or lith of a piece of artwork. The artwork is placed onto the copy platen via the peg bar to ensure registration to the film. The focus glass is placed in the film head. Adjustments are made with the copy platen position and lens position to achieve the desired image size. The focus switch is activated. The top lights come on. The shutter opens. And we can see the image to be photographed for focus adjustments. The focus function is turned off, the focus glass is removed, and the film head is reset for front film loading. The timer is set to the desired exposure time. The f-stop of the lens is set. We now turn off all lighting with the exception of a dim red light. Today we'll be using Kodak Kodalith high contrast black and white film in a 12 field size that is pre-punched to fit onto the Acme peg bar. Kodak Kodalith film will not react to red light, but if we were to use color film, all lights must be turned off and this procedure must be performed in total darkness. The vacuum motor is turned on, and the unexposed sheet film is placed onto the film head and the film head is closed. The start button is activated, which starts the exposure process. After the exposure is complete, the film head is opened, the vacuum motor is turned off, and the exposed film is removed and taken for processing. Thank you for watching our video of the Robertson Model 432 Mark II process camera. If you know of any details that we have overlooked or have any corrections, please comment below as our goal is for historic accuracy. Thank you very much.